So, you've probably seen those mind-blowing demos of AI agents, right? Stuff like Stripe's minions that can just take a task and run with it end to end. But how do you actually build the foundation for something like that? Well, today we're diving into a really disciplined approach called Agentic Platform Engineering. It's a scalable architecture that's all about taking AI agent intelligence from a fragile little setup on your laptop to a resilient enterprise-wide capability. Okay, let's start with a problem I am positive many of you have faced. You spend hours, maybe even days, getting your AI coding assistant just right. It knows your style, it knows your tech stack, all your little rules, and then you get a new laptop or tool updates, and poof, it's all gone. You're right back to square one. This isn't just a personal headache, It's a massive, massive scaling problem for teams.
Right now, the way most people handle this falls into two buckets. On one side, you've got ad hoc prompting, basically just typing into a chat window. Yeah, it works for a quick task, but the agent has zero memory. Then, on the other side, you've got a slightly better method, a single giant Agents.md file in your repository. The problem is, this doesn't scale either. It crams the same huge context into every single prompt, and it's totally trapped inside one repo. Let's be real, neither of these is real infrastructure.
So here's the big idea, the crucial shift in thinking. We need to start treating agent intelligence as infrastructure, not as some random improvisation. And the way to do that is with a really clean architectural pattern, a three-repo architecture. This isn't just some productivity hack. It's a blueprint for a system that's scalable, versioned, and distributable. Let's break down each part.
First up, we have the agent library, and I love this metaphor. Think of it as the agent's brain. This repository is the one and only source of truth for everything the agent knows. Its skills, its rules, its personality. But here's the most important part. It is completely tool agnostic. That means if you decide to switch from one AI coding tool to another, this brain stays exactly the same. All that valuable intelligence is preserved. Next, you've got the agent setup repository. This one acts as the bridge. Its only job is to connect the abstract knowledge in the brain to whatever concrete AI tool you happen to be using today. It's got a setup script that reads from the brain and creates symbolic links on your machine. This separation is what makes the whole system so incredibly flexible. Want to switch tools? You just swap out the bridge. The brain doesn't even notice. And finally, part 3 is the resource catalog, or what we can call the map. This uses the industry-standard Backstage format to create an index of your entire engineering ecosystem. Now, it doesn't have any agent logic in it at all. All it does is tell you, hey, that agent library exists. Here's who owns it, and here's where to find it. It's the high-level guide that keeps everything from becoming a chaotic mess.
So, we have the brain, the bridge, and the map. You might be thinking, okay, that seems like a lot of setup. So why go through all this trouble? Because the payoff is huge. We're talking tangible benefits in two areas that every single tech leader obsesses over: cost efficiency and system resilience.
Let's talk about token savings, because this is just dramatic. A monolithic Agents.md file can easily swell up to 15,000 tokens, maybe more, just stuffing every prompt with context that's totally relevant. But with this layered, directory-scoped approach, you bring that down to around 3,000 tokens. That's an 80% reduction, which means lower API bills, lower latency, and way better performance from the model. This quote from the source material just says it all, perfectly. With a single, giant context file, you're paying for Terraform rules when you're writing a Python script. It's so inefficient. The hierarchical design we're talking about makes sure the agent only loads the context it needs exactly when it needs it. No waste, period. And this just brilliantly shows how resilient the system is. Picture this, your laptop dies. Total catastrophe, right? How long do you think it would take to get your agent back online? Under 5 minutes. You just clone the 3 repos, run one setup script, and that is it. The agent's full identity, all its knowledge, all its skills, completely restored. This isn't just convenient. It's a solid disaster recovery model built on GitOps principles. Okay, so this setup is fantastic for a single developer or a small team. But what happens when you try to scale this to a huge enterprise? How does an agent from, say, the security team find and use a tool that's owned by the networking team without creating a total security and coupling nightmare? This is the enterprise discovery problem. Now, the solution is not to start sharing Git tokens around or giving agents direct access to other teams' file systems. That's a security disaster just waiting to happen. No, instead, we need to think bigger. We need to move from local symlinks to a network-routable service registry, treating agent capabilities like discoverable services on the network.
And the way we do this is actually surprisingly elegant. We use a well-established web standard, RFC 8615, which you might know as the .well-known directory. Team B just defines which of its tools are public. A CI/CD pipeline then compiles this into a standard JSON file and publishes it to a known URL. Now, Team A's agent can just ping that URL to dynamically discover what tools are available and what permissions it needs. It's secure, it's decoupled, and it's built to scale.
So let's zoom out for a second. What we've just described, it's not just about organizing files in a clever way. This three-repo architecture, combined with network-based discovery, is the fundamental groundwork you need for the truly autonomous, multi-agent systems of the future. Which brings us right back to where we started with those amazing systems like Stripe's Minions. As the source article puts it so well, this isn't a product you can just go buy off the shelf. It's a capability that you have to build piece by piece on top of solid infrastructure. Well, guess what? This architecture is that solid infrastructure. So, if there's one key takeaway, one mental model to walk away with, it's this. Think of this system as a package manager, like npm or pip, but for agent intelligence. The library.yaml is your package.json, declaring what should exist. And the setup.sh script, that's your npm install, wiring it all together. We're managing reasoning and behavior, just like we manage code.
So I'm going to leave you with this question. Your agent might be able to write some pretty good code today, but have you actually built the underlying platform to manage its identity, its knowledge, and its skills at scale? Is your infrastructure really ready for what's coming next in the world of autonomous systems?